Hello everyone, great to be part of this session. Let's dive right in. Let me start with what I think we can all agree on. Building secure software is hard and getting harder. Whether you're a developer, a tester, or a security lead, you're likely seeing the same roadblocks over and over again. Security bugs found late. Coverage goes missed. Regression slipping through. If any of that sounds familiar, you're in the right place. I'm going to walk you through a solution that flips the script. Shift-left static code analysis with built-in security compliance checks, AI-assisted unit test creation, and real-time code validation for test impact analysis will help you get rid of those roadblocks. What are you going to learn today? We will present you with how you can shift-left security practices with OWASP, CWE, CERT, and other compliance checks deployed directly within developers' IDE, within automation CI/CD pipelines, and on top of that, within reporting dashboards where you can consume full security compliance reports. You're going to find out how you can automatically create fully functional JUnit unit tests utilizing AI-assisted tooling, helping you drive your code coverage initiative forward. You will also learn how you validate code changes on the spot within seconds directly in your IDE, making sure that you do not introduce any regression to your code. Let's talk about discovering security issues late in the release cycle. The main reason that happens is the lack of automated compliance checks at the code level. By shifting security practices left and detecting issues directly in the code, teams can significantly reduce the risk of late-stage surprises, cutting both remediation costs and the chance of delayed releases. Also, while many teams perform some security checks, they often lack a consistent and structured approach, leading to time-consuming processes and unreliable results. How you can solve it is by shifting your security practices left by applying them directly within developers' IDE as well as within the CI/CD pipeline, while centralizing results in a unified reporting platform for full visibility. Let me show you how you can do that. As I work on the code within my IntelliJ IDE, I can perform a security compliance check against OWASP Top 10 2021 security standard. This way, I get an instant validation on the spot whether there are any security issues in my application, and I can make sure that I don't push those potentially insecure changes into source control system and then further downstream. I got some security issues detected. All of those issues are categorized by severity, from 1 meaning the highest to 5 meaning the lowest. Let's focus on some of those severity 1 issues. In particular, I'll take this one. If I double click on it, I move to the place in the code where the violation has been discovered. Print method print stack trace is not allowed in a catch block. I can open the documentation to get a detailed description of what that means and better understand why it is important from security perspective to address this issue. But even more importantly, I get an example of how the violation looks like and how the fix looks like. I can actually copy this piece of code and just paste it to my method to make sure that this violation is resolved. So rather than printing out explicitly an error message, we will just log it using a logger so that it's not exposed. I paste this line of code into my application, and then when I hit the save, the number of violations in this list will be reduced. You can see that the 2 violations have been fixed this way. Now, let's look at the other severity 1 violations over here. For example, this one, which is related to canonicalization of the data. I can select this one, but this time maybe rather than switching to the documentation, I will use AI. I will leverage AI to have it fixed for me. So I am asking AI to generate a suggested fix for this issue. What AI does is it checks this certain piece of code against this certain security standard. And what I get over here is the information that in fact this is the violation of the rule. And I also get a solution. So there's a piece of code that I can just copy and paste into my application. And there's another piece of code over here that defines canonicalize method, which I also need to paste to my application somewhere. And as I save the code, we've got this issue fixed as well. After addressing some of those security issues within my IDE, whether manually or leveraging AI, I would push the changes to the source control system, and the code would in turn be pulled from the source control system into the automation pipeline, where it gets executed, and security compliance analysis would be part of this execution. Directly on my automation platform, I can get detailed information on the issues being found during analysis, which weakness has been violated, in which line of code do we have a violation. So all this detailed information is being included directly within CI/CD pipeline. Nevertheless, what also happens within this automation framework is that the report is being pushed into the reporting dashboard, where I can get a full visibility into compliance report. So what I get over here is a full compliance report for OWASP Top 10 2021 security standard. I can see that my project is not compliant. I can get detailed information on why it is not compliant and for which weaknesses. So we are compliant with rule OWASP A1, but not necessarily with OWASP A2. And I can check exactly why is that. There are 35 violations associated with OWASP A2, and I can drill down to the line of code where the violation has been reported. Now, let's step back and look at the bigger picture. What you're really getting here is the ability to catch security vulnerabilities much earlier, before they become expensive, high-risk problems. By shifting security left and embedding automated compliance checks, like OWASP, CWE, or CERT, right into the code level, you're building secure code right from the start. This reduces the cost of fixes, minimizes delays, and gives your team confidence that they're aligned with key standards, all without slowing down development. Now let's shift our focus to another challenge many teams are facing: hitting their code coverage goals. Ensuring meaningful unit testing code coverage is essential for application safety and quality, and is often enforced through internal policies or external requirements. It is a tedious, resource-intensive, and time-consuming task, though. In fact, it accounts for up to 40% of development overhead. This is where appropriate tooling can make a big impact. With the AI-assisted Unit Test Assistant, developers can automatically generate fully functional JUnit unit tests. These tests can be enhanced with context-aware recommendations and AI-generated fixes, helping your team reach coverage goals faster and with less effort. Let me show you how it works. Let me switch to Eclipse for a change, which is yet another IDE supported by the tool. What we will be doing right now is we'll be creating unit tests for all the methods within item service class. As a matter of fact, I could also select a whole package as a scope of unit test creation, or maybe even a whole project. But for the purpose of this demo, it will be easier for you to follow what I'm doing within the context of a single class. In the bottom right corner, we can see a progress bar telling us what is the progress of unit test creation. We got to 100%, so within seconds we should get our unit test created. And what we get as a result is a fully functional unit test. Some mocks are getting injected over here. We are setting up those mocks. After the execution, we are releasing those mocks. And for each and every method in our source class, we get some tests created. Let me execute those tests. During the execution, we'll be collecting coverage data, and we can see that we are getting quite a decent coverage for item service class, 86%. It is a very high number. But on top of that, we are also getting recommendations from the tool. Some of those recommendations are related to potential setup problems. Some are related to exceptions being thrown. Some are related to possibly mockable method calls. Some are related to uncovered code or missing assertions. For example, this first one is telling us that assertion failed during test run because an unexpected exception was thrown. We can mark this exception as expected, and the next time we execute the test, we should not get failure, but this test should pass. But I want to focus on one particular test, that is test for update item method. I can select it from the list, and only recommendations linked to this particular test will be highlighted. So there are some possibly mockable method calls. But what will be particularly interesting for me will be to see which lines of code have not been covered and whether we get a recommendation that we can do something about it. So I'll focus on this one recommendation at the end of the list. It says that uncovered code has been detected, and I can modify or duplicate an existing test case to cover the code. Furthermore, I am getting hint that to cover the code, item repository exists by name method should evaluate to true. So I can easily clone this test, and I can make sure that exists by name method is in fact returning true. And if I execute this test now, I should hopefully get those two lines of code covered. And here we go. This way, we were able to further enhance the coverage that I'm getting on that particular class. Now, so far I've been relying on our own proprietary framework to create our unit tests. Our proprietary framework produces reliable, consistent, and predictable results and can be easily used on its own, which will guarantee high quality of the tests being created. Nevertheless, what the tool also offers is an integration with external LLMs, which can be leveraged to further increase the quality of the tests being produced. LLMs have better semantic understanding of the code, thanks to which they can provide more meaningful inputs for the tests. What I am doing right now is I'm creating unit tests for category service class with our proprietary framework, but what will also happen in the process is we will send a request to external LLM provider to further enhance the quality of the inputs being used for testing. 31 test cases have been created for 10 different test methods, and 7 of those test cases have been fixed with AI to provide more valuable inputs. If we'll take a look at the code of our test class, you will notice that some of the values have been provided by LLM. For example, external AI provider was able to understand that category in our store should be something like electronics. It was able to provide meaningful description. it was able to provide a path to PNG file as an image over here. Also, whenever, for example, URL is needed, AI is able to understand how this URL should look like. This is an example one. This is one referring more to an API which can provide the list of categories in our store. But what I can also leverage the AI to do is to make some changes in those tests that have been created. I can take one of those tests and I can try to improve it with the AI. There are some predefined improvements over here, like adding edge and error cases or converting to a parameterized test, but I can also provide a custom hint. For example, provide a more meaningful name for the test method. I submit this request to LLM provider, and the code is being produced, which includes a new name for our test method. When I click apply, those changes are being applied directly within the code. So now my test method is called update category should throw parameter exception when parameters are invalid. This is a more meaningful name, and it is easier for the person who is looking at those tests to understand what this particular test is actually doing. What I can also do is leverage AI Assistant to do the same thing in bulk for me. Actually, with AI Assistant, I can send any custom hint to try to make changes or improvements for my tests, or maybe answer some questions that I may have. In this case, I will ask my AI Assistant to provide more meaningful names for all the test methods within category service test class. And what AI Assistant is doing is it is actually printing out some new suggested names for the test methods that I have in place. So, what does this mean in practice? Autonomous test creation with AI-assisted refinements and optimizations can save you up to 70% of the time typically spent on reaching your coverage goals. That means faster development cycles, fewer blockers, and more time for teams to focus on writing great features, not boilerplate tests. Now, let's talk about something every developer dreads: introducing a bug that breaks something downstream. You make a small change, CI runs for ages, and hours later you find out something went wrong. Or even worse, it goes unnoticed until production. Why does this happen? It usually comes down to not knowing what to test. Running the full suite takes forever, and running nothing is a huge risk. That's where smart test selection comes in. Instead of running everything, you get instant validation of your changes right inside your IDE. Only the tests that are relevant to your changes are run, so you catch regression issues early without slowing down your workflow. Let me present to you how that works. For my role service class, I have already created some unit tests which cover all of the executable lines of code. Now, if I modify my code, I would like to make sure that I did not introduce any regression to the existing functionality. In order to do that, I need to execute unit tests. But which unit tests should I execute? My instant guess would be that I need to execute those tests that are present within the role service test class. That is understandable that we have unit tests that cover lines of code within add new role method in this role service test class. But maybe there are other tests in my entire test suite that do cover lines of code within add new role method. If I cannot understand which tests need to be executed, I would need to execute all of the unit tests that I have in place. But then I may have thousands and thousands of those tests, and it may take ages to validate that the changes that I have introduced do not represent any regression for the current functionality of my code. And that's where impacted unit tests come in handy. Please watch carefully what happens when I hit save within the editor. Focus on the view on the right side. Once I save the code, you can see that the impacted unit tests view selects all the unit tests that have been impacted by recent code changes that I have introduced. That is, all the unit tests that need to be re-executed in order to validate the changes that I have provided. Obviously, we have some tests within role service test class, but there are also some tests that have been created for a different method within different class, but they happen to cover some lines of the code within my add new role method. All those tests, as I hit save within the editor, have not only been properly selected, but also executed on the spot. We can see green markers telling us that all of those tests have passed and that my changes have been validated. I did not introduce any regression to my code base. I get this validation right on the spot. Now, what I've noticed is that now I have one line of code that actually is not covered. So what I would like to do is I would like to automatically create unit tests for that line of code. What's happening right now is the tool is creating unit tests for all the lines of code that have been modified since I last pulled my code from my source control system. The test has been created and the test has been executed on the spot. So I instantly know that the test is passing and code coverage gets recalculated. So I now got the last line of code within my class covered. What you get is that instead of waiting for CI to catch regressions, maybe hours later, you're catching them instantly right where you're coding. Live, focused, and fast. By validating code behavior on the spot with only the tests that matter, you avoid regressions before they ever make it past your local branch. It's not just faster, it's smarter testing built right into your workflow. That concludes the presentation. Thank you for tuning in, and we will be happy to take your questions now.